Hello and welcome to module 5 of our Exploit Development Basics series. In this module, we'll cover how to write Unicode compatible exploits. So these are the few tools and software that I'm assuming that you as a learner have a basic knowledge of. If you don't, please check out the resources mentioned at the end of this video. So this is our module structure and we're on the first part, that is introduction, wherein I give you a brief overview of the technique that we will be learning in this module. These are the tools required for this module. We'll be needing a virtualization software. You can use either VirtualBox or VMware. We will be needing two machines, one running Linux and one running Windows. I will be using these as a virtual machine. And for Linux, I will be using Kali Linux 2018.1. On Kali Linux, I have installed Python 2.7, Sublime Text or Notepad++. And I will also be needing Alpha 2 or Alpha 3 encoder. For Windows, I will be using Microsoft Windows 7 SP1 as a VM, and on this machine I will be running FileFuzz to fuzz our target application, Immunity Debugger, Mona library for Immunity Debugger, Trilogic Media Player 8, which is a target software, Sublime Text or Notepad++, and Python 2.7. The download link for these tools and software is mentioned in the description, so please check it out. So what is Unicode? Unicode is a standard for encoding computer text in most of the internationally used writing systems. In simple terms, it means that it is a standard to represent the character set of most of the written languages of the world. Now, a benefit of Unicode is that it is 4 bytes, that is 32 bits, and it can represent a large number of characters, whereas ASCII is 7 bits and it is somewhat limited in the number of characters it can represent. Many applications which have an international reach are now using Unicode 16 as their preferred character encoding standard. Now, why is it a limitation for us? Primarily because it converts a buffer into Unicode format before it is stored into a stack. What this means is that the application will transform each byte that we send as part of a shell code and convert it into a Unicode compatible format as shown here. So in the example here, a buffer of 41, 41, 41, 41 has been converted into 0041, 0041 and so on. So in this case, X00 has been prepended to each of these bytes and this changes the meaning of the original byte. Now, how do we work around or bypass this limitation? Now, in order to write a Unicode compliant exploit, we will first have to find a memory address that looks something like this. We'll only need to send it these 2 bytes and these will be converted into this memory address wherein 00 is prepended in front of both bytes. Then we'll need to find a Unicode compatible knob which essentially will help us in continuing our execution flow without affecting the state of the registers. And then we'll need to align the CPU register to the beginning of our shell code, and we'll generate a shell code using MSFNM, but we'll encode it using Alpha 2 encoder to generate the Unicode compatible shell code. To read further about Unicode compliant exploits, please refer to the FRAC article mentioned in the link. If this all sounds a bit confusing, don't worry, we'll cover this technique step by step and things will get clear in further videos. So these are the few learning resources you can use to learn more about the tools and techniques that we are using in this module. Thank you for watching this video and I'll see you in the next part.